Hello, can you hear me? Okay. And you can also see my screen, right? Okay. So let's start our today's training. Today is our last training, and today's content is simple, so it will take no long time to finish it. Today we will talk about TouchProbe function of our driver. First, uh, what's TouchProbe? Here, this function is used for high precision measurements and control. This function is mainly used to record the position of the motor. So, for example, in some package machine, we may need some iMark or something else to detect and record the position. So this function is mainly used to record the position of the motor. And you will maybe some people will ask, we have MC read position. We have this function block in our, for example, in our PLC. Why not use this function block to record the position? Because MC read position, this function block uh, is over. It's a CAD communication. So it means, for example, you connect the iMark to uh, input of PLC and use the rising edge. For example, use rising edge of the input to to move to record the position we read from MC read position function block. But in this way, because they have communication delay, maybe 1 ms or 2 ms, so it will cost the real position when the motor achieve the iMark. The real position will be different with the reading position because they will have a communication delay to get the position. So we have this torch prop function. This function we need to use DI input of driver to record the position, so it will not be affected by communication. It means we will use driver to record the position first and store this position information in driver, and then we use PLC to read the position. So the order is different. And here for our driver, we can use uh, D, uh, DI signal, DI signal to trigger the position recording, or we can use motor Z signal to record the position. And for this configuration, we need object dictionary. I will show you that object dictionary later. And below are some application about TouchProbe. So here, before we use TouchProbe function, we only need to set this several parameter. For our driver support two TouchProbe, pop 1 and 2, and they are default as DI5 and DI6. So it means you can connect an iMark or sensor signal to DI5 to use pop 1, and you can also connect it to DI6 to use pop 2. So this is the wiring. And here we don't need to set any parameter because the default function of DI5 and the DI6 is already a TouchProbe function. And this is the object dictionary we need to configure it in our controller. First one is 60B8. This index is used to configure our TouchProbe. And we have another index 60B9. This is used to read the TouchProbe status. And there are other four object dictionary used to store the position of the motor. Because for each prop we can use rising edge or falling edge to store the position. So here for each prop we have two object dictionary to store the position information. And this is the details about TouchProbe function and the TouchProbe status. We can check the TouchProbe function first. Here you can see this index is a 16-bit address. So for the low 8 bits is the configuration for prop 1, and the high 8 bit is the configuration for prop 2. So we can see the low 8 bit. Bit 0 is used to enable our prop. So if you want to use it, we need to set this bit as 1. And the second bit, bit 1 is used to set the trigger mode. We have single trigger and a continuous trigger. A single trigger means after we get the signal from DI or the Z signal, the position will be stored in driver one time, and the next time the signal come again, it will not to update the position. This is single trigger, but if we set it as continuous trigger, then every time when the trigger signal coming, the driver will read the position and update it to the object dictionary where we store our position information. And the bit 4 is bit 2. Sorry, bit 2 is used to set the trigger signal. We have two selection. 0 means DI5. It means we need to connect IMARC to DI5. And you can also set it as 1. 1 means Z signal. Z signal means we don't need to connect we don't need to wire in CN2 terminal. The position will be updated according to the motor Z signal. And the bit 4 and bit 5 is used to enable the rising edge and falling edge. So this is the configuration for prop 1, and the prop 2 is same with prop 1. Only one difference is here. If we want to use DI trigger, for prop 2 we need to use DI6, and prop 1 is DI5, and other is same. Okay. And here I have some notice when using TouchProbe. First, when use the same prop, for example, when use prop 1, it's not command to use the rising edge and the falling edge in the same time. It means it's not suggest to set these two bits as 1 and the same time. But you can use, for example, a rising edge of prop 1 and falling edge of prop 2 at the same time, it's okay. And the second, if you are using Z signal, only rising edge is support. Here, if here we use Z signal to trigger, then here we can only use rising edge to get to keep in the position. And the last is for a single trigger. For single trigger type, if we want to change it to if we want to how to say to record the position again, you need to first set this object as 0 and then configure it again. This is for single trigger. And configure it in PLC. First is send to add the EtherCAT slave. And here, if you want to use only PDO configuration to for this function, here we need to delete the motion axis. Because if you didn't delete this axis, the axis mapping and the PDO mapping will have a conflict. It will cost. It will make your operation on PDO will not take effect. And enable expert parameter and configure the PDO input and output. This part is same with our another floor class, another floor training. And this is my configuration. First, for output, here I configured control word TouchProbe function. This 60B8. We have a table just now. We just check it. And also here have a target velocity because in my test in my demo I use I make driver run in CSV mode to make it running all the time and use TouchProbe to record the position. And here for input we have position actual value and TouchProbe 1 rising edge value and TouchProbe 2 flowing negative value. These two. Okay. So here, and also after configuring the PDO, we need to create its variable and map it to our PDO. And here, for example, for TouchProbe 1, we enable it, and we use continual trigger and use G signal to record, and use rising edge, because for G signal we can only use rising edge. So finally, For the low 8-bit, we should set it as this one 0 0 0 0 0 0 1 0 and 1 1 1. This is our low 8-bit. And for here, for the POP2, we also use first we enable it and we use continue trigger and the DI6 to trigger here 0. And we use a falling edge, so here 0 and this falling edge 1 and 0 0. So this is the high 8 bits. And combined the low 8 bits, we will get this value. And it is 8,983. So we need to set this value in object dictionary 60B8. Now let's check the effect. First, here we have actual value, actual position. And set the control mode to 9. 9 is CSV mode. And set control word to enable the driver. And for the TouchProbe function, we set it as this value. And then set the target velocity. Okay, now the motor is running with this speed because it's a 16-bit motor. So this value means 30 RPM. And change to 60 RPM. First here, for the TouchProbe 1, you can see the stored value is always changing. Because here for POP 1 we use Z signal. So every time when the motor rotates one loads, we will get one Z signal, and the position will be updated one time. Change to 300 RPM. And for TouchProbe 2, for POP 2, we use DI6 signal and the falling edge to trigger it. So here in the video, I change the DI status manually by changing the panel. So every time when I set the DI6 from on status to off status, this position will be updated one time. Falling edge to record. Okay, so this is the usage of the TouchProbe function of our VD3E. So we only have one list. We only need to configure this object dictionary and map list for the object dictionary to the variable to read the position. So you will find this function is easy to understand and to use. And our today's training is finished. Thank you for your attending. Bye.